Today we'll say question number 5. The question is question number 5 from 10.2. Prove that the perpendicular at the point of contact. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. So you have to prove that if you draw a perpendicular at the point of contact of a tangent, then it passes through the center of the circle. So say we have a circle and AB is a tangent at P, and at the point of contact we have drawn O'P perpendicular to AB. We have drawn O'P perpendicular to AB. We have to prove that O'P passes through the center. So given is a circle with center O, then AB is a tangent at P, and what O'P is perpendicular to AB, to prove what O'P passes through the center O. Okay, for this we need the construction. We'll join this OP. We'll join OP. Okay, proof. Okay, we have drawn OP perpendicular to AB. At the point of contact P, we have drawn the radius, or we have joined O and P, so we have drawn the radius at the point of contact. Now we know that radius and tangent are perpendicular to each other, so we know OPB will be 90. Angle OPB is equal to 90 degrees. By since tangent perpendicular to radius. Again, what is given to us? O'P is perpendicular to AB. That means O'PB is also 90 degrees. O'PB is also 90. Since O'P is perpendicular to AB, is given. Okay, you can mark it 1, mark it 2. So from 1 and 2, what are you getting? Both are equal to 90. So from therefore what are you getting? Both are equal to 90. That means they will be equal. OPB equal to, sorry, it's O dash. O'P. So O dash PB. Okay, so what are you getting? We're getting this, say, O'PB equal to OPB, or OPB equal to O'PB. So we're getting this angle and this angle equal. We're getting these two angles equal, but in the figure, if you see, they are not equal. If you see the figure, they are not equal. O'PB and OPB are not equal, right? But we got them equal. Now, this is possible only when this is possible only when OP and OSP coincides. This is possible only when OP and OSP coincides. Now, coincide means if they are same straight line or if they are same line. Now, if if OP and OSP coincide, that means they will be the same straight line. And since angle since OP is passing through the center, that means OSP also will passes. If that coincides, since OP passes through center O, OSP also will pass through the center O. So this is possible only when OP and OSP coincides. Therefore, OSP passes now since OP passes through center O, therefore OSP passes through center O, and that is what you are supposed to. Okay, write it down. If you're done, you can raise a hand. Okay, fine. Let's move to the next question. Question number 6. The length of a tangent from the length of a tangent. Sorry, we have done this. Number 7. Two concentric circle of radius 3 and 5. Find the length of the chord of the larger circle which touches the smaller circle. Okay. So we have two concentric circles. Concentric means they will have same center. If two circles have the same center, then they are called concentric circle. Two concentric circle of radius 5 and 3. Find the length of the chord of the larger circle which touches the smaller circle. So AB is a chord of the larger circle and it touches the smaller circle at the point P, say, and O is the center. And the radius of both the circle are given. For the larger one, the radius is 5. For the smaller one, the radius is 3. So for the larger one, radius is OA or AO, It is how much? 5. OA is 5, and the radius of the smaller circle is OP, so it is 3. You have to find the length of the chord, that is AP. You have to find the length of the chord, that is AP. Okay, what is given to us? Two concentric circle with center O. Concentric with center O. Then AB is a chord of the larger circle. And touches the at P and touches the smaller circle at P, and the radius of the larger circle is 5, so OA is 5, and small circle is 3, so OP is 3. To find what? AP. Okay, here we cannot find AB directly. We'll try to find AP. We'll first find AP and then we can find AB. We'll try to find AP. Okay, we know what tangent and say if the chord AB is touching the smaller circle at a point, then AB is a tangent. So AB is a tangent to the smaller circle. And we know what radius and tangent are perpendicular to each other, or tangent and radius are perpendicular to each other. So we can take angle OPA or APO equal to 90. We can take angle APO equal to 90, or we can mark it 1. We can take angle 1 equal to 90. And if angle 1 is 90, AOP or OAP is a right triangle, so we can apply Pythagoras theorem. Okay, so let's take it, and we can use Pythagoras theorem, and we can find AP, and then we can find AP. Okay, first angle 1 is equal to 90. Why? Tangent perpendicular to radius. Okay, so in right triangle, OAP, what you can use Pythagoras theorem. So we can take what the hypotenuse is, what OA, so OA square will be equal to what? OP square plus AP square. Then put the value. OP is 3 and AP we don't know, we are going to find. We are putting the value from given. Now solve this. Mm, 5 square is how much? 25 equal to 3 square is 9 plus AP square. Now we're going to find AP, so take this 9 to the other side. And 25 minus 9 is how much? 16. Find AP. How to find AP? We'll take root, and root of 16 is how much? 4. Therefore, we can write AP equal to 4. Now, since we got AP, we can find AP. Okay, now in class 9, we have learned that In class 9, we have learned that perpendicular drawn from the center to the chord bisect the chord. So if there is a perpendicular from the center to the chord, OP is a perpendicular from the center to the chord. So it will divide the chord into two equal parts. That means AP and PP are equal. AP and PP are equal. Okay. So, and if AP and BP are equal, what you can take? We can directly take AB equal to twice of AP or twice of BP. Okay. Perpendicular drawn from the center to the chord, bisect the chord. It will divide the chord into two equal parts. So AP and BP will be equal, or each part will be half of the whole thing, or the whole thing will be 2 times of any part. Whole thing will be 2 times of any part. Now we can take what? Okay, for this, I need a little space. So I'll drop the first part. Okay, I'm running this also. So we can write AP is equal to 4 cm. Now we can find AB. AB will be equal to 2 AP. Why? Since perpendicular drawn from center to the chord bisect the chord. Perpendicular drawn from the center to the chord bisect the chord. This is class 9 theorem. What you have learned in class 9, we are using it here. So we know that AP and BP will be equal, or the whole thing, AB, will be 2 times of any of this part. Whole thing will be 2 times of any of this part. We found out AP, so AB we can find it. So AB we can take 2 AP. So it will be 2 into 4. That means AB is equal to how much? 8 cm. Okay, once you're done, you can raise your hand. Some more hands if you're done. If you're done, raise your hand. Okay, fine. So let's move to the next question. Question number 8. A quadrilateral ABCD is drawn to circumscribe a circle. So this is a quadrilateral, ABCD is a quadrilateral, ABCD is a quadrilateral, and it is circumscribing the circle. That means 4 sides of the quadrilateral will touch the circle at 4 different points. And you have to prove this. Okay, let's see. So A, no, is down. A, B, C, D is a quadrilateral. Is drawn to circumscribe the circle. That means the 4 sides are touching the circle at P, Q, R, S. And what is the proof? You have to prove AB plus CD equal to AD plus BC. Okay, given is what? So we'll just mention the center. A circle with center O. Or, okay, here we don't need the center also. We can write a quadrilateral. ABCD is drawn to circumscribe a circle with center O. Okay, since it is circumscribing, the side AB, BC, CD, and AD are touching that AB, BC, CD, AD touches and AD. Circle at P, Q, R, and S respectively. So side AB is touching the circle at P, BC at Q, CD at R, and AD at S respectively. To prove what? AB plus CD is equal to AD plus BC. Okay, proof. Okay, now here, if you look the figure, look at this. Now it is very important. We're going to use a theorem that is tangent from the same external points are equal. Now look, from A we have 2 tangents, AP and AS. AP is a tangent from A, and AS is also a tangent from A at P and S. So from the same point A we have 2 tangents, so these 2 tangents will be equal. Again, from B we have 2 tangents, so these 2 tangents will be equal. Again, from C we have 2 tangents, so they will be equal. Likewise, from D we have 2 tangents, DR and DS, so they will be equal. Okay, so first we'll take that. Now, while taking, say we need AB and CD. AB and CD are opposite side. 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 So all the part of AB and CD will keep it on the left. We know that tangent AP and AS will be equal, so we'll take AP equal to AS, not AS equal to AP. Then we know that BP and BQ will be equal. So we'll take BQ equal to BP. So say part of AB, I'm keeping all the part of AB, that is AP and BP, I'm keeping on the left. And same way, all the part of CD, that is CR. We know CR will be equal to what? CQ. And DR will be equal to what? DS. So all the part of AB, that is AP and BP, and all the part of CD, that is CR and DR, all the parts of AB and CD, I'm keeping on the left. That one you have to keep in mind to do this problem. Otherwise, you'll not get the answer. So all the part of AB and CD, since AB and CD are on the left in the proof, so what are you going to do? All the part of AB and CD, we are going to keep it on the left, and we'll mark it 1, 2, 3, 4. And why they are equal? The reason is same. Tangents from the same external points are equal. Tangents same external point to the circle are equal. Tangents from the same external point to the circles are equal. Okay, then we'll add 1, 2, 3, 4. If you add 1, 2, 3, 4 on the left hand side, we'll get what? AP plus BP plus CR plus DR. And if you add AP and BP, we'll get AB. And if you add CR and DR, we'll get CD. Okay, I need to rub the first part. I think you have written. Okay, adding. What we'll get? While adding for equation, we add, while adding some equation, we add all the left hand side together and all the right hand side together. So add the left hand side together and the right hand side together. Okay, now if you see the figure, AP plus BP, AP plus BP is what? AP plus BP is AB. So instead of AP plus BP, I can write AB. And CR plus DR, CR plus DR is what? CD. CR plus DR will be CD. Again, AS plus DS, AS plus DS will be AD. If you see the figure, AS plus DS is what? AD. Plus BQ plus CQ is what? BQ plus CQ is what? BC. So this is what your answer proves, so hence proof. Okay, if you're done, you can raise your hand, and there will be one extra class as I given you the message at 11:30.